Hello friends. So in this experiment we are going to discuss about the LVDT trainer. Okay. So theory regarding LVDT we already discussed at the time of theory classes, and through this video we are going to see how the LVDT works practically. So the LVDT is nothing but a linear variable differential transducer, so which senses the linear movement. Okay, so at the time of measurement of anything, so whatever the input coming from the instrument, so that will sense by this LVDT, and this linear movement we are going to read digitally. Okay, and after calibration, that unknown quantity also displayed on the instrument. So in this experiment we are going to see how the linear variable differential transducer works. Okay, so this is the experimental setup. Okay, this is the LVDT actually. Okay, so this is the outer shell of LVDT. Inside this, core is going to move, and inside this there are the primary and secondary winding. So connection is then further given to the digital display. So here there are two buttons, zero adjustment and span button. Okay, so there is a one micrometer which is used for the known source. Okay, so when we move this microscope by say suppose 1 mm, then at that time the reading of 1 mm will shown on this display. So for known source the micrometer is given. So both the way we are going to read the movement, linear movement, and we compare this linear movement. Okay, means when we are going to turn one complete revolution of micrometer, then we are going to check whether this LVDT is going to show the reading of 1 mm or not. Okay, so now we are going to start with experiment, and two or three reading we may observe. Okay, so at this particular moment, so at a zero. Okay, so for any reading I will set this micrometer and rotate this micrometer by one complete revolution. Okay, so after rotation of one complete revolution, then we are going to observe the readings. Okay, so see the readings. So it is going to set, so near about 1. Okay, so for 1 mm it is going to showing over there 1. Again I am going to rotate this with one complete revolution. It means that I am going to shift 1 mm out. Okay, so total reading 1 plus 1, that are going to show the 2 mm or near about 2 mm. So the micrometer, after micrometer, the result at the LVDT display is 2.02. Okay, then in a third reading, again I am going to rotate this micrometer barrel with a one complete revolution. It means that the third reading for this is near about 3 or 3 point something. So after setting the results are on the display that are near about 3. Then again I am going to rotate this micrometer by one complete revolution. Then the fourth reading is displayed on the display. So after the setting out the results, we will get the result at display. Near about 4.02. Okay. So such a way that when we move this micrometer linearly, so inside and outside, so when we move this micrometer outside, then it will show the positive reading, and when we move the micrometer in this direction, then it will show the negative reading, means 3 2 1 0, like way. That means through this experiment we conclude that, so when this core is moved inside and outside, then practically we observe this movement of inward and outward movement is going to display in the form of actual distance of movement of this core. And for that purpose, here we use the micrometer. So because of that we will get exact reading. Okay, and we compare these two reading, म्हणजे means after rotation of one complete revolution it will show the 1 mm over here. After rotating two revolution it will show 2 mm over here. After rotating third revolution it will show 3 over here, and after rotating fourth revolution it will show 4 over here. So linear motion of any instrument will sense by this LVDT, and easily we display it digitally. Okay, so thank you.